Assalamu alaikum, my name is Abu Bakr Ali and today we are going to start another past paper of A levels. It's variant 1-2 from year May-June 2025. Okay, so let's begin with the first question. In the first question of this paper, they're asking what must all physical quantities have. So all physical quantity must have magnitude and the units. Okay, so it's option D. Pretty simple question. In the question 2, you have to convert this number into this unit. So basically you have to remove this kilo and millimeter from here. So let's write down the number first. It is 0.25 kilo Newton per millimeter square. Okay, so this thing will come as it is 0.25. The kilo can be written as 10 power 3 and Newton will come here. Okay, when you have to put the value of milli, but you have to keep in mind this millimeter per meter square is basically, it has a power on both of them. Okay, so this you have to keep in mind. This is the main trick in this question. So when you open this thing will be equals to milli, we know it is 10 power minus 3, so it will have whole power minus 2, and this per meter square will come here, and this can be written as 10 power minus 3 into minus 2 will give you 10 power 6. So this thing can be simply written as 10 power 6. Okay, now what we can do, we can separate these two and we can simplify, we can multiply these three with each other. Okay, so these will give you 250023 Newton per meter square when you multiply them. It's option D you have. Okay, in the next question, a student calculated the density of the solid cube in an experiment. The measured value is given and the measured length is also given. What is the density of the steel? Okay, so if you look at the options, the data is mass is given in grams, their options are given in grams. Okay, the length is given in millimeter, but here the units are centimeters. So let's first convert that thing. It can be written as length is equals to, when you convert milli into centi, you have to divide this thing with 10, so it will give you 5 centimeter plus minus 0.1 centimeter. Okay, so density is mass per unit volume and volume of cube is L cube. So when you put the values here, mass is 975 divided by 5 cube, so you will get, let me calculate this thing. Okay, so what we have, 975 divided by 5 cube. This will be 7.8. Okay, this is the mass you have. Now we have to find the percentage uncertainty. Okay, so let's make some space here. So if you have to find percentage uncertainty, what we can do, if you see the relation is density is mass over L cube. So what will be the basic formula, basic equation for that thing? That percentage uncertainty of density will be equals to percentage uncertainty of mass plus 3 multiplied by percentage uncertainty of L. Why we have multiplied this thing with 3? Because there is a cube on the length. Okay, so that power factor will be multiplied by that thing. Okay, so percentage of M will be delta M over M multiplied by 100 plus 3 into percentage of L will be delta L over L multiplied by 100. So that will give you G, you have 10, delta M is 10 over 975 multiplied by 100 plus 3 into 0.1 divided by 5 multiplied by 100. So let's do the calculations. This thing will give you 7.02%. okay, you can, that can be rounded off to 7%. It's option B you have, that is the right option. In question 4, the time period of a simple pendulum is given. Okay, so you have to find the value of n here. Okay, so it's the question from the units. Equation is homogeneous, it's mean the left hand units, the units on the left hand side will be equals to the units on the right hand side. So if we write the equation, t is equals to, we can ignore this thing just because 2 pi are the simply numbers, L over G. Okay, so in term of units, L will have a, T will have a units of seconds, it's a time. L will have units meter. G is the acceleration, it has a unit meter per second square, and they have whole power n. On left side power is 1. Okay, so this m will cancel out with m. This thing will give you s power 1 will be equals to, this s is minus 2, when it go on the numerator it will be s power 2 whole power n. It can be written as s ki power n, s power 2n. So if you see both the bases are same, there is a s, there is a s, so 1 can be written as 1 is equals to 2n. When bases are same, the powers will also be comparable, so n can be written as 1 by 2. So option C you have. Okay, so in the next question, radio waves can be used to measure the distance between the Earth and the planet Jupiter. Pulse of radio is emitted from the Earth and it's moving to the Jupiter and is detected on the Earth. The time between the emitting and receiving the pulse is given. What is the distance? Okay, so let's first try to visualize that thing. Let's suppose this is Earth and there is somewhere Jupiter. The sound, the electromagnetic wave is going there and it's coming back. Okay, total time duration is given. You have to find the distance between, you have to find one-way distance. Okay, so what we have to do, we know distance covered, or you can say distance traveled by the wave is speed multiplied by the time. Okay, speed of electromagnetic wave is constant, that is speed of light, 3 into 10 is power 8. Time is already given 3960. When you multiply both of them, you will get a very big number, that is 1188000000000 9 zeros. Okay, but what we have to find, we have to find separation between them, the distance between the Earth and Jupiter. So separation, or the distance between Earth and Jupiter, let's call this s, it will be s by 2. It will be half of it because wave is going towards the Jupiter and then it's coming back, so that is the distance traveled by the wave. So if you have to find the separation between the Earth and the Jupiter, you have to divide this thing with 2, so that will give you, when you divide it, 594 meters. Okay, we have options in kilometers, so when you change this thing in kilometer, you have to divide with 1000, it will give you kilometers. So it's, how many zeros are there? 1 2 3 4 5 6 7 8. So it can be written as 5.94 10 raised to power 8 kilometer. So it's option A we have. Okay, so in next question, the graph shows the variation with time of the velocity of a car. Which statement is correct? You have to tell. Okay, so you have to analyze all of the statements one by one. Let's start with the A. A car accelerate for 2 seconds, then stop for 4 seconds. Its accelerating for 2 seconds, but it's not stopping, it's still moving at a constant speed. So A is wrong. The car accelerates at 12 meter per second for 2 seconds. So if you have to find the acceleration of this, you have to find slope. Rise is 12, run is 2, so slope will be 6. It's not 12. Okay, it's wrong. The car travel a distance of 36 meter in first 4 seconds. So let's work this thing out. So if we have to find, this is the 4 second, so you have to find this area and you have to find this area. This area will be 1 by 2, base is 2, height is 12, that will give you 12 meter. And you, when you work out this area, the base is from there to there, it is 2, and the height is 12, that is 24. So 24 plus 12 will give you 36, so that option is correct. Distance under area under the graph will give you the distance covered simply. In the next question, a solid object of mass 1 kg fall vertically downward in a vacuum. So it's moving in vacuum, its mean acceleration will be equals to g. Mass is given. When the speed of the object is this, an additional force of 50 newtons suddenly start to act vertically upward. Okay, what is the speed of the object 2 seconds after the additional force acting on the object? Okay, so what is the given scenario? Object was falling freely, and at a particular point there is some force that will act on it, that is in the upward direction. So the object will start slowing down, it will decelerate. So what are the forces acting on the object? There is one force acting downward, it is weight, that is m into g. As mass is 1 kg, so 1 into 9.8 give you 9.81 Newton. Okay, and at that point additional force is acting upward, that is 50 Newton. Okay, you have to find final speed. Okay, so this speed at which the force acted, you can consider this thing as a initial speed. It was at 60, okay, when this force acted. Then this thing will, for how much time? For 2 seconds you have to tell the speed here. Okay, so you know the u, you know what it is. U is 60, v is, you have to find, t is 2 seconds, a is unknown. You don't have acceleration because at this point additional force is acting on that object, that is upward direction. So you have to find this deceleration first. So we can use the Newton's second law, F is equals to ma, so a will be equals to F over m. This F, you have to keep in mind, is always a resultant force. So 50 is acting upward, 9.8 is acting downward, so it will be 50 minus 9.81, and mass is 1, so 50 minus it will give you 40.19. So acceleration is, and we will take this as negative because this is deceleration. Okay, for this thing you can take the 50 negative as well, but this is the deceleration, so acceleration will be taken as negative. So we have minus 40.19. This should be meter per second square. Okay, meter per second square. So we can apply the equation of motion simply. V is equals to u plus at. So v is equals to 60 plus minus 40.19 into 2. That whole thing will give you 20.38 meter per second. That can be 20. Okay, it's option A. Okay, so in next question, a stone is thrown upward and follows a curved path. A resistance is negligible. Again, why does the path have this shape? Okay, why the path have this shape? Why this object is not moving straight upward? Why it's coming back towards the ground? The stone has a constant horizontal acceleration and constant vertical velocity. If you look at this object, they are telling A resistance is negligible. It means there is only one force that will be acting on the object, that will be the force of gravity. So gravity, this will cause acceleration. In which direction? Vertically. Gravity always act vertically, right? So you can say if there is a vertical acceleration, the vertical component of the velocity will not be constant. And as there is no horizontal force, there is no air resistance, there is no horizontal acceleration, so the horizontal component of velocity will be constant simply. So it will be, this thing is constant horizontal acceleration, wrong. There is no acceleration in horizontal. The stone has a constant horizontal velocity, yes, because acceleration is 0, and constant vertical acceleration, yes. Vertical acceleration is constant, that is equals to g, because there is no air resistance, and constant horizontal velocity because there is no force acting in horizontally, so velocity will not change. It's option B. A rocket engine ejects 90 kg of exhaust gas per second at a velocity of 190 meter per second relative to the rocket. What is the force acting on the rocket due to the ejected gas? Okay, so what we can do, we have mass, we have time, and we have velocity. What is the force acting on the object? So we know F is equals to m into A, right? Or you can say we have delta P over T. Okay, so this delta P is change of momentum. It can be written as mv, as initial velocity will be 0, so it will be T. M is 90, velocity is 190, and divided by 1. Time is 1, it's for the 1 second, so this thing will give you 17100. It can be written as 17 kilonewtons. It's option B that is correct. In question 10, which statement does not describe an elastic plane between the two objects? Not describe. The relative speed of approach of the two objects equal to the relative speed of separation, that is describing the total kinetic energy of the object is conserved. Yes, in elastic it is conserved. The total kinetic energy of the object is reduced. No, it will not be reduced. Okay, so this is not describing the elastic plane. A cyclist is riding at a constant speed on a level road. According to Newton's third law of motion, what is the equal and opposite backward push of the... Okay, so if back wheel applying a force on the road, simply road will apply a force on the back wheel. There should not any third object involved in this thing. The one that is doing the action on something, that object will face the reaction force. So back wheel is doing the action, so reaction force will also be on the back wheel. So it should be option B. Okay, and the next question, a stone is released from a rest and fall a long distance in the air. Whenever they say a long distance in the air, they are referring towards terminal velocity. Okay, which graph could show the variation with time t of the acceleration of the stone? Okay, some of the students, without looking at the axis of the graph, they just mark this option without realizing that it's not a velocity time, it is a acceleration time graph. So this is not an option. As object is moving down, remember object will start at maximum acceleration, that will be equals to g, and that acceleration will decrease with time, and it will be eventually equals to 0 at the terminal velocity. Okay, secondly, so we have to choose between option B and D. Okay, A is not the option, C is not the option, because acceleration should decrease and it should reach to the 0. But there are two options, B and D, both satisfy this condition. One is linear, one is non-linear. You have to keep in mind the change in acceleration is non-linear. It's not a linear thing, okay? Because as the object is speeding up with time, the air resistance will increase, that will decrease the resultant force. That decrease in resultant force is not a linear thing, okay? It will show you a non-linear response. So it's option D. Okay. In the next question, an empty cart is moving with a horizontal truck at a constant velocity. Resistive force acting on the carts are negligible. A heavy rock is dropped vertically into the cart. This is the cart, and this rock is going to be dropped on into the cart. The cart continue to move horizontally with the rock. Okay, so they both are colliding sort of, and after collision they are going to move along with each other. So this type of collision is inelastic collision. You have whenever two objects are colliding with each other and after collision they move along with each other, this collision is inelastic. So now let's look at the option. The cart with the rock inside has a smaller momentum and a smaller kinetic energy. What you have to keep in mind, momentum never changes, okay, in any of the collision. So this is not the option. The cart with the rock inside has a smaller, no. The cart with the rock inside has the same momentum, yes, momentum is always same, and a smaller kinetic energy, yes. In inelastic collision, kinetic energy will be lost, okay, it will not be conserved, so it will not be same, okay. In the next question, a wooden block is held stationary in a container of water using a string that is attached to both the wooden block and the bottom of the container. The wooden block has a mass of m and a volume v. The water has a density this. What you have to find, you have to find the tension. Okay, just look at the scenario. This is the container in which this is the liquid, and there is some object that is hanging. It's not hanging basically, it's in between of the liquid, and there is a string attached with it. What this string is doing here, this string is not letting this object float on the surface. So this string is applying a force that is downward, and this force is basically the tension that you have to find, okay. There is another force that is acting on the object, that is weight, mg, okay. And why this object is not coming down? Because there is another force acting on it, that is the upthrust, that we write as rho gv. So these are the three forces acting on it, and this object is stationary, it's not moving. It's mean that the upward forces rho gv must be equals to sum of downward forces mg plus t. You have to find t, so this mg will go there, it will be rho gv minus mg. So this will give you option D, okay. Okay, so in the next question, a square shop sign of uniform density has a mass of this and a sides of length given. There is a frictional force in the hinge so that the sign hangs from the equilibrium at an angle of 15. But you have to find movement about the hinge of the weight of the sign, okay. So if we zoom in into this problem, the weight will be acting exactly at the center because it's a uniform sign, right? So weight will be like this. So this is the point where the force is acting, and okay, so you have, this is the pivot point. Distance from the pivot till the force, this is, if total is 0.86, this will be equals to 0.43, half of it exactly, okay. Now what we have to look at, if you remember the definition of movement, it is the force multiplied by the perpendicular distance, right, to the force. So we have to find the components of this weight. There are two components of this weight. One will be the perpendicular to the surface like this, and one will be along the surface like this, okay. We are not interested in this because of this component, the line of action is passing through the pivot point, it will not produce any movement. We are interested in this thing, okay. So this is, if this is weight, this will be the angle theta, this will be mg cos theta, okay. The most common mistake, student consider this theta as 15 degree. That is wrong. Why that is wrong? If you look at this thing, this thing is making a triangle. Okay, let's draw it here. This thing is making a triangle where it's this side is 0.43, this angle is 15. Okay, so and this angle is 90 degree. Okay, this angle theta relates with this angle, not this one. So you have to find this angle of the triangle. Okay, if you remember the inclined plane model, if there is some inclined plane, if this is angle theta, the weight will act vertically. Let's suppose the object is here, the weight is acting like this, the perpendicular component is like this, angle will be theta. We never said this angle will also be equals to theta. This is not the case. This angle and this angle will be the same angles. Okay, so you have to find this. This is 15, this is 90, so this angle will be 180 minus 90 minus 15. That thing will give you 75 degrees. Okay, so this will be, this force is basically m is also given. This force is 2.4 into 9.81 into cos of 75 degree, and the distance is already given, so movement is F into D. This is 2.4 into 9.81 into cos of 75 multiplied by 0.43. This thing will give you 2.62 Newton meter. Okay, it's option A. Okay, and the next question, a block is submerged vertically in a liquid. The four diagrams shows the block viewed from the sides. Which diagram shows to scale the forces exerted on equal area of the block in the liquid? So this is basically the force on a liquid is rho g v. Okay, or you can say that force is, it can be written as rho g, volume is area into depth. Okay, if you see all they have, they're all in the same liquid, same density, g is constant, area of the all blocks is also same. What is different? This depth is different for all the points. So how much force is acting on the sides of something, on which area, depends on its depth. As you see, these points, the top points, are at a least depth. Okay, so this whole area should have a same force. Okay, so they are all showing same force. Okay, as you move down, the force should increase gradually. But one thing more, this thing is shown in A and this thing is shown in C as well, that as you're moving down, the force is increasing gradually. The force is increasing gradually. But C is not the right option. The right option is option A. Why? If you see this point and this point, they are almost at the same depth. This point have a force of that much and this is less than that. It's not making sense. There they are almost same. If you see this arrow, this scale and this scale are showing the same force. Okay, and as you're moving down, the force is increasing. So option A is correct. That is how you have to compare them. Okay. Okay, the next question, the diagram shows a couple. How is the torque of a couple calculated? Simple definition, perpendicular distance between the forces multiplied by magnitude of one of them. It's option B. In question 18, a ball of mass is given travel horizontally at a speed of this. The ball hits a cushion and comes to rest. Okay, so you have initial velocity, you have the final velocity at a distance of this. What is the work done by the cushion on the ball to bring the ball to the rest? Okay, so when the ball is moving, it have kinetic energy and it's going to strike the cushion. So it work done to stop this thing should be equals to its kinetic energy. So it will be stopped. That much energy, that much work you have to do. So it will be simply 1 by 2 mass into velocity. 1 by 2 mass is 1.2, velocity is 3 square. So it will give you 5.4 joules. Option C. Okay. In the next question, a box of mass 4.9 kg is pushed at a constant velocity from a point P at the bottom of the inclined plane from plane towards the point Q. The box is pushed by a force of 64 Newton parallel to the slope, and slope is inclined at 20 degree, and box moves through a vertical height of 5.8. What is the work done against the frictional force acting on the block? Okay, so if you have to find the work done, you need force, you need distance. Okay, the object is the block is moving on this path, so you need, this is the D, and you have to find the frictional force. So let's work this thing. Okay, so what they are telling us that the velocity is constant. It's mean the forces acting along the plane and down the plane, they will be equal. So if you see, if this is the object, the weight will be like this, there will be this angle will be 20, and there is another component of weight, there's another component of the weight that is acting like this. It will be mg sine of 20. That is one force that is acting down the plane, and there is another force that is a force of friction, let's call it small f. Okay, and as the velocity is constant, it's mean the frictional force plus mg sine 20 should be equals to 64. Then it can move with the constant velocity, right? So f will be equals to 64 minus mg sine of 20. We know m is 4.9 into 9.81 into sine of 20 degree. That thing will give you, when you calculate f, we get 47.55 Newton. Okay, now you have to find the distance D. So by using simple trigonometry, this is the perpendicular, this is the hypotenuse, so we can use sine theta, sine of 20 is equals to 5.8 divided by D. So D will be 5.8 divided by sine 20. That thing will give me 16.9 meters. So work done will be simply 16.9 into 47.55, and when multiplying both of them, we will get 806.3. it can be, it's closest to 810. Okay, so option B is correct in that case. The next question, which expression give the efficiency of a system? So efficiency is simply a useful output energy divided by the total input energy. In question 21, student has a copper wire and a steel wire with an equal length and a cross-sectional area, and identical loads are hanged with it. Extension of the two wires, that extension is different. Okay, you have to find which quantities are same and which are different. So we know stress is force over area, and in the given question is given that loads are same, areas are same, so stress will also be same. Okay, so you have to choose between option A and D. Okay, so strain is basically change in length over original length, and change in length is different, so strain will also be different, and Young modulus depends on stress divided by strain. As strain is different, so Young modulus will also be different. So it will be option A. Okay. In the next question, two springs X and Y stretch elastically. The graph shows the variation with extension. And which statement is correct? Okay. So when each spring is given the same extension, the energy stored in Y is 4 times the energy stored in X. So let's try this one first. Each spring should given the same extension. So this extension is 5. So when this will also have extension 5, it will have a force of 10 Newton. Okay. When you half the extension, the force will also the half of it. Hooke's law. Okay. So you have to compare the energy. So for energy, we have a relation E is equals to 1 over 2 F into X. So it will be 1 over 2 10 into 5. That will give you 25. And here 1 by 2 F is 80. X is 5. So it will give you 200. So you have 25 and 200. What is their comparison? 200 divided by 25 gives you 8. So it's not 4 times, it is 8 times. Yes. Okay, it's option B that is correct. And 23rd, which phrase describes the strain at the elastic limit on a stress strain graph? Elastic limit. Okay, elastic limit is the point where till which the Hooke's law is applicable. Okay, the force and extension or the stress and strain are directly proportional to each other. So it is the minimum strain above which the deformation is plastic. Yes, we can say the minimum strain above which the okay. Okay, before this it is elastic, and after this it will be plastic. The deformation will be permanent. Okay. In question 24, a teacher removes the turntable from a microwave oven and places a bar of chocolate in the oven. A stationary wave is formed in the oven. When the chocolate is removed, the observer observes the two small sections of melted chocolates 6 centimeter. Okay, where the chocolate is melted, it's mean there is a maximum amplitude of the wave, maximum energy is delivered. So that point will be the antinode. Okay. And as we know, on the corners there are always nodes of the wave. Okay. So if we want to make, there should be a node, there should be a node, and there should be a antinode. Okay. So it will be like this, the wave. Okay. So at the point where it is melted, there will be a antinodes, and on the corners there is always a node. Okay. Assume the speed of the microwave is this. You have to find the frequency of the microwave. Okay, so frequency, we can use the wave equation. V is equals to F lambda. So F is equals to V by lambda. V we already know, we need lambda. Okay. So how we can find the lambda? We know this thing is 6 centimeter. So if I consider this thing, this complete pattern shows lambda. Okay, and if we divide this thing, this is lambda by 4, this thing is also lambda by 4, and this thing is also lambda by 4, and this thing is also lambda by 4. So we have this portion is lambda by 2. This is the half of the lambda. So half of the lambda is equals to 6 centimeter. So lambda is equals to 12 centimeter. So you can put this thing here. 12 can be converted into the meters for the calculation. So it will be 3 into 10 raised to power 8 is the speed. It will be 0.12. You will get 2.5. You will get 2.5 into 10 raised to power 9 hertz. You have to convert this thing into mega or gigahertz. So giga is 10 power 9, it can be written as 2.5 gigahertz. Okay, it's option C that is correct. Okay. In the next question, a sound wave travel from left to right. The graph shows the variation of displacement to the right of the particle in the sound wave, which later represent the center of the compression. Okay, so wave started from this point and it's moving right way. This thing is showing the displacement and this thing is showing the distance covered by that thing. So you have to tell which letter represents the center of compression. So it is started from there, then it will expand. Okay, so it will be, this will be the expansion point, maximum displacement, that is the rarefaction of the wave point, and then it will move back, and again zero displacement, it will be the compression. So this B point is the compression of the center of the compression. In the next question, a buzzer emitting a sound of frequency that is given to you. So this is the frequency of the source, is attached to a string and rotated in a horizontal circle. The linear speed of the buzzer is given. So this is the velocity speed of the source, Vs. The speed of the sound is also given. You can simply write as V. What is the maximum frequency heard by the observer? You have to find maximum observed frequency, F naught. So this topic is from Doppler's effect. We have equation, you have to find F maximum. So the relation for the Doppler effect is F naught is equals to Fs into V divided by, you have two options, V plus Vs or V minus Vs. So for the maximum, the denominator should be smallest, so it will be V minus Vs. Okay, so this will give you a maximum observed frequency. You just have to put the values, 846 340 divided by V is 340 minus 25. This thing will give you 913. In the next question, vertically polarized light I naught is incident normally on a polarizing filter. Transmission axis is at angle theta. The intensity of the light after passing is this. Okay, so this thing is basically I that is given. You have to find the angle theta. So the relation we have is I is equals to I naught cos square theta. So I is equals to I naught by 3. I naught will remain there, cos square theta. So this will cancel out. So we will have 1 by 3 is cos square theta. So to remove the square, you can write it as cos theta is equals to under the root 1 by 3. This thing will give you 0.57. So theta is cos inverse 0.57, that will be 5473. Make sure your calculator is in degree mode, not in radian. Okay, so it will be option B that is correct. Moving forward, which statement compares the behavior of a transversal and longitudinal waves? Okay, so transversal wave is the only wave that can be polarized. We can't polarized the longitudinal waves. Okay, so option D is correct. Okay, a student uses a diffraction grating to determine the wavelength of a visible light from a source, and what we have in that case 300 lines per millimeter. The student measures the angle theta of each order n of the intensity maxima, and the graph is given for n and sine theta. The line of best fit is plotted, and that is called G. Which expression represents the wavelength in meters of the visible light in term of G? Okay, and what the G is the gradient. So for the diffraction grating, the basic equation we have is d sine theta is equals to n lambda. Okay, so d is equals to n lambda by sine theta. We have to represent that thing in term of g. So g, we know it's the gradient. Gradient is rise over run. Rise is n and run is sine theta. Okay, I just want to introduce this g into the equation. So n over sine theta here can be written as g. So it is g lambda. So you can say d is equals to g lambda, and you have to find the expression for the lambda. So lambda can be written as d over g. Okay, so we have to choose between option, this b is not correct, a is not correct. We have to choose between option c and d, and we have to find value of d. So what the d is now? So d is basically, you have to find, is equals to 1 over n. N is basically the number of lines in 1 meters of a diffraction grating, right? So if you have to find n, n is number of lines in 1 meter. What we have 300 lines as given in question in 1 millimeter. So how many lines, or n will be equals to how many lines will be in 1 meter? Okay, or 1 meter can be written as 1000 millimeters. Okay, so I can put it here 1000 millimeter. Okay, do the comparison method, you will get n is equals to n over 300 is equals to 1000 over 1. So n will be equals to 300 multiplied by 1000, that will be 3 into 10 raised to power 5 lines. Okay, so this n can be substituted here, 1 over 3 into 10 raised to power 5, that will give you 3.3 into 10 raised to power minus 6. So this g can be written, this lambda can be written as 3.3 10 raised to power minus 6 divided by g. That is option C. Okay, moving forward, two waves meet. What is not a necessary condition for the waves to produce a stationary waves? They must be of the same type, they must have the same period, they must have the same wavelength, they must travel. Okay, this is not the condition that you need for the stationary waves. Okay, all the other conditions are required. Light of a single wavelength is incident normally on double slit. Interference fringes are observed. The distance from the double slit to the screen is 0.6, that is capital D, and the fringe separation is 1.8, that is basically x. The distance from the double slit to the screen is 0.9. Okay, what you have to find, you have to find what is the new fringe separation. Okay, so it's the double slit experiment. The basic relation we have is x is equals to lambda d divided by a. Okay, all the other factors are constant. If we can say x is, if lambda and a are constant, x is directly proportional to d. So as we know, when if we compare x and d, when x is 1.8 millimeter, then d is 0.60 okay meters. What we have to find, we have to find new x. What will be the x when d is increases by 0.9? It was already 0.6 and increases by 0.9, it means 0.6 plus 0.9, that will be equals to 1.5. Using the comparison method, we will get x over 1.8 is equals to 1.5 over 0.6. So x is 1.5 into 1.8 divided by 0.6. So that thing will give you 4.5 millimeter. It's option C, that is correct. Okay. In the next question, a wire is made from a metal of a constant resistivity. There is a constant current in the wire. Which statement about the potential difference across the wire is correct? Okay. It is a constant resistivity and a constant current. So you have to comment on the potential difference. We know V is equals to IR from the Ohm's law. Okay. And if the current is constant, V will be directly proportional to R. Okay. And we also know R is directly proportional to the length. So we can say V is directly proportional to the length in that case. If A is proportional to B and B is proportional to C, then we can say A is proportional to C as well simply. So it will be option A. It is directly proportional to the length of the wire. In the next question, the IV characteristic for 3 electrical components are shown. Which component obeys Ohm's law? Ohm's law is V is directly proportional to I, right? And R should be constant. So it is only 1. That is option D. Second and third are not obeying the Ohm's law. Okay. A resistance of 200 ohm is connected to a supply of potential difference 4. How many electrons enters in 4 seconds? Okay, so you have to find number of electrons. We have a relation V is equals to I into R. Okay, so and I can be written as total charge is equals to number of electrons multiplied by the charge on a 1 electron divided by T. So if you put that thing here, it will be N into E divided by T and multiply by the R. You have to find N, so N is equals to V, T will be multiplied when going there and divided by E and R. Okay, so when you put the values, what we will get, voltage is 4 multiplied by time is also 4, charge on electron is 1.6 10 raised to power minus 19, and R is that charge on electron will be given in the formula sheet. Okay, and resistance is 200. When you do these calculations, you will get 5 into 10 raised to power 17. It's option C, that is correct. Okay. Okay, so let's move with the question 35. The diagram shows a cell of internal resistance 1R connected to a variable resistor, and when the variable resistor has a resistance of 2R, the current is I1 and the terminal potential difference across the cell is V1. Okay, so this is the cell and the potential difference across it is, you can say, V1 initially. So whatever the potential difference is here, that will be here. They both will have the potential V1 initially. So what is the new current in the cell and the new potential difference across the cell? Okay, so let's work it out. Previously, the total resistance in the circuit, our total is, this is 1R plus this is 2R, so this thing will give you 3R. This is the total resistance. Okay, so if you have to find the current that is passing through this thing here, okay, from here to here, so I1 will be equals to V1 over the resistance of this resistor. This will be 2R, I can write it as. Okay, okay, so what changes they are telling us? What is happening? The variable resistor is now adjusted to a new resistance of 4R. Okay, so what is happening now? The new resistance, you can say R2, sorry, this is the R total, is now, this will remain same, this will remain, this will become 4R, so this will give you 5R. So what is happening in actual? Resistance was 3.0R and it is jumped to 5.0R total resistance. Okay, as the EMF is constant, we know current is inversely proportional with the resistance. So how much resistance is increased? We can say resistance is increased by a factor of 5/3. Okay, if you multiply this number with 5/3, you will get 5R. Okay, so its mean I should decrease by the same factor, 5/3. So I can say the original was I1, the current, the new current I2 will be equals to I1 and it is decreased, so you have to divide by 5/3. That will give you 3/5 I1. Okay, so when you divide both of them, this will give you 0.60 I1. So A and B are not the option, we have to choose between C and D. Okay, let's work out the voltage now, what we have to do with it. Okay, so what is happening here? You have to tell this voltage V2 here. Okay, so this V2 can be written as voltage is equals to I2 into this resistance of the variable resistance, that is 4R. Okay, so it can be written as 4 into I2R, and I2 I already know it is 0.6, so it will give you 4 into 0.6 I1 into R. So 0.6, it will be into 4 is 2.4 I1 R, that is V2. But we need the answer in term of V1, so I have to change this thing into V1. So let's look at the equation. We can work out with this equation. We know 2I1R is equals to V1. So I1R is equals to V1 over 2. So I can put this thing here. So I will get V2 is equals to 2.4. In place of this I1R, I am going to put this value, that is V1 over 2. So V2 is 2.4 into V1 divided by 2, that will give me 1.2 V1. So it is option D that is correct. Okay, so let's move to the next question. The diagram shows a 4-terminal box connected to a battery and 2 ammeters. The current in the 2 ammeters should be identical. This means we are looking for a series circuit. Which circuit within the box gives this result? Okay, if you look closely to all of the circuit, option D is correct, because when you attach this thing here and this slot here, this will give you the series circuit. The current will start from here, it will have a path like this, same current will move from here and it will move back to the battery. Okay, in next question, each of Kirchhoff's 2 laws presume that some quantity is conserved. Which row state Kirchhoff's first law? Okay, so you just have to tell the Kirchhoff's first law. It talk about the algebraic sum of current at a junction is 0, so charge will remain conserved. Second law is about the energy. Okay, in the next question, the 2 neutral atoms are isotope of same element. Which statement about the atoms are correct? The atoms, they have different number of neutron and same number of proton. That is a simple definition of isotope. In the next question, what is the composition of mesons? Mesons are always made from one quark and one antiquarks. Okay. The last question, a nucleus of carbon 11 contains 6 protons and 5 neutrons. So let's work it out. Carbon is 6 proton, 5 neutrons, so its mass is 11, its charge is 6, and it is emitting beta. So when it emits beta, this carbon will change into 11 and this will be 5. It's beta positive. That is why this proton will be decreased by one number. Okay. What we have to tell, what is the total number of up and down quarks in this? So let's work this thing down. We have to look at this thing. What we have in this case, we have n is equals to number of neutrons 11 minus 5, that is equals to 6, and protons are equals to 5. So you have 6 neutrons and 5 protons. So if we work for the protons, we know each proton is made up of UUD, up and down quarks. So 5 UUD means it will have 5 into 2U plus 5 into 1D. So it will have 10 up quarks plus 5 down quarks. Okay. And when we talk about the neutrons are made from UDD. So you can write it as neutron is, how many neutrons are there? 6 neutrons. So this will be 6 into UDD. It can be written 6U plus 6 into, it will be 6U plus 12D. So 10 U's here, 6 U's here, so total are 16 U's, okay, in carbon, and 5D and 12D, it will be 17 D's, okay. So 16 and 17, the option B is correct. Okay. If you have any question, any query, you can ask me in the comments. Thank you.